inside the ETS room. ETS means energy transfer systems. In this room you will find the heat exchanger. Okay, so there are three numbers of heat exchanger are there. We will discuss about the distribution of the heat exchanger. Well, so you can see there are two circuit. One is primary line. This is the primary circuit which is connect with the distribution company, which may be Tabrid in Abu Dhabi, Emco in Dubai, and this is the white line which is insulated. Okay, so white insulated, this is connected with our building. The secondary line connected with our buildings unit such as FCU, AHU, FHU, whatever available at our building. Okay, so now we will start from the chilled water distributions. Okay, so in primary circuit which is connected with the breathe. Okay, so this is the chilled water supply. You can see here, this is the chilled water supply line. The bottom it is connected with bottom side. This is the chilled water supply, and this is the chilled water return. Okay, this is connected with top of the heat exchanger. This is the supply, this is the return, and this is the primary circuit. And here also, okay, you can see the white line. This is the supply, this is the return of secondary circuit. Okay, this is the bypass. You can see in the chilled water secondary line. Well, so this is the butterfly valve. You can see here, by the butterfly valve you can isolate and regulate your chilled water supply. So after that, this is the pressure gauge. Okay, you'll get to know the pressure of chilled water line. So it is mentioned now 80 psi, and this is the temperature, and the chilled water supply it's showing here. You can see here, this is below than 10. Okay, so this is the temperature gauge and supply and pressure gauge. Every day you need to check this thing to make sure your ETS is in normal condition. Then this is the PT, pressure transmitter. Okay, so which is connected with our connected with our PLC, programmable logic controller. Okay, after that, this is the testing pot. Okay, so as per your requirement also, you will if you want to check the chilled water flow and chilled water temperature and testing purposes, you can check by here. Then this is the DPT for monitoring the strainer. This is the strainer in chilled water supply line, and you can see there are one primary side and secondary side. Okay, so both are connected in the chilled water line, and this is the DPT, differential pressure transmitter. If your strainer block, if your chilled water line block, then the DPT will transmit the data to the PLC for this information. Okay, so after that, again there is a butterfly valve to isolate and regulate the chilled water line. So these are the equipment you will find in the chilled water supply of primary circuit. And in the chilled water secondary, okay, so there is also temperature gauge, pressure gauge, and there is also TIT, the blue color you can see. This is the TIT, means temperature indicator transmitter. And there is also a actuator valve which is configured with PICV. PICV means pressure independent control valve. Pressure independent control valve to balance the chilled water line. And again there is a differential pressure switch you can see here. Okay, so differential pressure transmitter DPT. Then after that, again butterfly valve, and it is connected with the main line of the distribution company. So well, so now we are moving to the secondary circuit, which is connected to our buildings unit like FCU, AHU, and the FHU. Okay, so this is the chilled water supply. There is a temperature gauge, pressure gauge, and this is the DPT, differential pressure transmitter, which is monitoring our by the PLC. And this is the secondary supply, and there is the bypass line. In the event of any maintenance or as per the requirement, we can open the bypass line. Okay, well, so this is how the chilled water distributed from the heat exchanger. Now we are moving to the PLC. Before going to PLC, just I would like to mention here, our secondary circuit is connected with the secondary pump, and the pumps are operating by VFD, variable frequency drive. Okay, so how your VFD will adjust the frequency? There is a DPT installed in the riser line. Okay, so end of the riser. This DPT will sense the PLC for increase and decrease the speed of the pump. Okay, so DPT, the motor frequency VFD operating by DPT, differential pressure transmitter. Okay, so now I am in front of the PLC. Now I am going to switch it on. Well, so this is the display. You can see here. Okay, well, so you can see here, this is the primary supply and this is the return. This is the primary circuit. This is supply and return. Supply, the circuit temperature is 40.1 degree Fahrenheit and return is 50.6 degree Fahrenheit. And the pressure, supply pressure is 74.1, return is 61.3. You can observe here the temperature, there is a difference in the temperature and there is difference in the pressure. Okay, so temperature increased in secondary in return line and pressure decreased in the secondary line. So that is called delta T and delta P. Delta T means the difference in temperature between chilled water return and chilled water supply, and the delta P means the difference between chilled pressure in return line and pressure in supply line. And this is the chilled water flow. The flow is 628.0 GPM. GPM means gallon per minute. Okay, so this is our chilled water supply parameter. Then you can see here there are some isolation and regulating valve. Okay, so this is the supply, this is the return. In the return line, as I told you, there is PICB. PICB means pressure independent control valve, and this is the DPC, differential pressure switch for the which is monitoring to the pressure of chilled water circulation. Okay, so these three heat exchanger, AGX means heat exchanger. Then this is our secondary line. Secondary line supply is 41.5 degree Fahrenheit, return is 58 Fahrenheit. This supply is going to our FCU, AHU, FCU, and this is the return line from FCU, AHU and FHU. Okay, so that is how our chilled water distributed in heat exchanger systems. I hope you understood about chilled water distribution in the energy transfer systems like heat exchanger room. Thank you.